All right, guys, target C and target D. Here we go. All right, we're going to say that it hits this second spot, even though it kind of doesn't look like it. Then we say, how much does it go up? Well, it looks like it goes up from 20 to 40, so it goes up 20. And then it goes over 2 boxes, but how much are 2 boxes worth? It's worth 4, up 20 over 4. 20 divided by 4 is 5. So we have y equals 5x. There's the slope, and it starts at 20, so plus 20. All right, number 2. What's the equation here? Instead of, whenever they give you letters in the equation, instead of x and y, they want s and w. Okay, starts there. Now it hits there, but I don't know what this number is. So you know what? I'm going to skip this point, and I'm going to go to there because it's easier for me. So it goes up 10, from 0 to 10. It goes up 10 over from 0 to 1. So it goes up 10 over 1. So it's just y equals 10x, but they want us to use s and w. Okay, so s equals 10w. Great. Okay, let's see. This one I thought was, okay, let's see. It starts at 0, 0 and goes up 120 over from 0 to 1. Okay, up. So let's see. The slope is not 1/120th. It's 120 over 1. Yes. So it goes up $120. That's what it goes. When you're going up, we're doing dollars. Every 2, so up $120, and sideways, when we go sideways, we're doing days, every 1 day. Okay, let's see. $120 every 1 day. Not $1 every 120 days. See. All right, number 4. This one's kind of tough because it's tough to tell what is going on. It's basically, we have 2 options. Are we going up 60 over 1, or are we going up 1 over 60? Well, if I look at this, it looks like we're going like up 60, like right halfway to, a little past halfway to 100. So that doesn't, even though it doesn't look like it, apparently that's 60. A little more than halfway. So it's going up 60 and then it's going over 1. So we're going up 60 over 1. So it's not this guy and it's not this guy. So how much, when we're going up dollars every 1 day. Up dollars over days. So $60 every 1 day. $60, where is that? $60 every day. That's that one. All right, number 5. Let's see. S and W, instead of X and Y, S and W. Okay, let's see. I'm gonna use that one, and I'm gonna use that one. This one goes up 10. It starts, if I start here and go from there to there, I'm actually going 2 boxes, but they're worth 10, 0 to 10. So up 10 over from 0 to 1. So I'm going up 10 over 1. Y equals 10x, but what they want S and W. Y equals 10w. Okay, whatever. Number 6. All right, let's see. Up 20 over 4. 20 divided by 4 is 5. So this would normally be x and y, right? But now we're just using c and w. So, okay, c equals 5w. There's the slope, so it goes with the letter. We would normally say y equals 5x. Okay. 7. Same thing. Let's see. Up 10 over 2. 10 divided by 2. This would normally be 5, so y equals 5x. But they want c and w, so c equals 5w. There we go. Number 8. What is this? Let's see. Starts at 4, so it's going to be y equals something, something, something plus 4. That's where we're starting. And the next box I can trust looks like it's right there. So if we go up from 4 all the way up to 16, right? That's how high we go. So 4 to 16 means we went up 12. How much did we go over? 4 boxes, but how much is that? We went from 0 over to 8. Up 12 over 8. Okay, these are both even. Let's cut them in half. 6/4. They're still both even. Let's cut them in half. 3/2. Y equals 3/2 x plus 4. All right, let's say we want to do that trick that I told you, that when you get this, you don't trust your reducing. You're like, I'm just going to throw it in my calculator. If you do 12 divided by 8, it's 1.5. So you could also say y equals 1.5x plus 4. So you could throw it in your calculator like that, or you can reduce it like that, but it can't be 12/8. So whichever one you feel good doing. Number 9. Let's see, up 24 over 4. 24 divided by 4 is 6, so y equals 6x, but c's and w's, so c equals 6w. Does it change the math at all? No, not at all, just a different letter. All right, let's see. Y equals, we start at 8 plus 8, and we go up to there. Is that the first one that it hits? Yeah, it looks like it. So it goes from 8 all the way up to 32. So how much is that? Let's see, 32 minus 8. That tells me how far I traveled. I actually went 24. So I went up 24, and then I went over from 0 all the way over to 8. Up 24 over 8, that's 3. Y equals 3x plus 8. And that was it for that one. Okay, let's do target D. Okay, let's see. 20x plus 28 minus x. If I have 20 x's minus 1 x's, I really have 19 x's plus 28. So over here, I have 19 x's plus 28. Okay. Number 2, let's see. I can plug these guys in, or I can actually do the math. I'm going to make, what am I going to do? I'm going to make this negative 9 times bigger. So negative 9y's minus 81 x's. Ew, this is gross. Negative 9 times 23 is positive 207. Ew, this is gross. Okay, let's see. 9x's versus negative 9x's is done. 81 versus negative 81, or 1 versus negative 81 is negative 80x's equals, let's see, 207 minus 55 equals 152. Did I do this right? 152 divided by 80 is 1.9. Ew, this doesn't look like I did this right. Okay, did I do something wrong? Negative 9, negative 81 equals 23 times 9 equals 207 minus 55, 152. Huh. Why does this seem wrong to me? 9x plus, oh, that's why. Gee, many, I'm an idiot. Okay, this problem even got me. Okay, 9x plus y equals negative 55. These aren't lined up in the right order. I didn't even look at it. I'm so used to seeing, these are y's, so I have to rearrange them. So I'm gonna line up the 9x's plus y's equals negative 23. Now, how the heck could, okay, well, let's multiply this one by negative 1. Negative 9x minus y equals positive 23. So now when I do this, 9x's kill off negative 9x's, and y's kill off negative y's. I've got nothing on this side. Equals, let's see, negative 55 and 23 is negative 22. 0 does not equal negative 22. There are no solutions. Whoa, that one got me. Because we have to have the x's and the y's lined up. I didn't even notice. I'm so used to doing these problems, I just didn't even notice that they were the wrong letters. Ooh, got me. Okay. Number 3, which ones of these have no solution? Okay, on this side, I have 20 x's minus 10 x's. So I'm going to end up having 10 x's over here. I have 7 x's over here. They're not going to cancel out. So this is just one answer. Over here, I have 12 x's minus 4 x's. I have 8 x's. Over here, I have 8 x's, so they're going to cancel out. And then I'm left with 5 equals 11. No solution. Over here, I have 16 x's minus 8 x's. What I really have is 8 x's minus 9. Over here, I have 8 x's minus 2. The 8 x's are going to cancel each other out, and I have negative 9 equals negative 2. Never, no solution. Over here, I have 4 plus 10 x's. Over here, I have 7 plus 10 x's, because 15 x's minus 5 x's is 10 x's. The 10 x's are going to cancel out. 7 equals 4. Nope, never. Let's see. Number 4. Enter what the x is equal to. Okay, if I want to figure out the x, what I'm going to do is kill off the y's. So let's make this 6 times bigger. So now we have 30 x's plus 6 y's equals negative 48. Okay, let's go. 30 plus 1x is 31 x's equals negative 48, and 17 is negative 31. We're going to divide by 31. And x equals negative 1. Okay, let's see. Number 5. A system of 2 linear equations has no solution. The first equation is x minus 2y equals negative 18. Select the second equation that would have infinitely many solutions. Okay, so we want to have infinitely many solutions. Okay, so we should have x minus 2y equals 18. Which one of these is exactly... infinitely many solutions means it's the same equation. Let's see. Are any of these look like they're the same equation to me? Actually, yeah, this one looks like the same equation. You know why? What happens if I multiply this equation by 3? This becomes 3x minus 6y equals 48. So yeah, they are the same equation. I just made it 3 times bigger. That's something I'm allowed to do. They're exactly the same equation. Number 6, let's see. 24x plus 32 minus x means I have 23x's plus 32. So that there's one solution, if I want there to be one solution, I can't have 23 x's over here, because that means I'll have like 0 solutions or infinity solutions. So I'm going to put any other number besides 23. I'm going to put 42 x's plus 57. As long as I didn't put 23 in that box, because then the x's would have canceled out. All right, enter a number in the box to create an equation that has an infinite number of solutions. All right, 5 times 4 is 20x. 5 times 3 is, this is hard to see, 20x's. 5 times 3 is plus 15 minus x equals something x plus something. Okay, we want infinitely number of solutions. So we want the x's to cancel out, and we want this other number to be the same. So we have 19x's plus 15 over here when you subtract the x from 20x's. So if I want this side to have infinitely many solutions, I have to have the same amount of x's so they cancel out. So I need 19x's over here. And then when we cancel these guys out, we need to have the same number left. 15 equals 15. So if I want them to be infinity, they need to be the same x's, the same everything. Is this a hard paper? Yeah, this is pretty hard. A system of 2 linear equations has no solution. The first equation is 3x plus 5 equals negative 5. The second equation would have no solution. All right, the way it's going to be no solution is if they're the same equation, but they equal something else. So this is the same equation, but it equals something else. How would that be possible? So I know 3x plus y equals 7. How could 3x plus y also equal negative 5? If I multiply this second one by negative 1, then I have negative 3x minus y equals 5. And look, everything cancels out. Everything cancels out. And we have 0 equals 12. No solution. Basically, how could 3x plus y equal negative 5? And then how could 3x plus y equal 7? There's no way the same numbers could equal 2 different things. That would be no solution. Number 9. All right, this is one of those. How many years after tree was... Okay, so one tree starts small, one tree starts tall. But this small tree grows fast. This big tree goes slow. Eventually, they're at the same height right there. When is that? That's at 40 years. 40 years from now, they'll be the same height. And finally, number 10. Okay, let's see. A tree that is 6 feet tall is growing at a rate of 2.5 feet per year. So it's 6 feet right now, so it starts at 6, and it grows 2.5 feet every year. All right. A tree that is 16 feet tall, so it starts at 16, and it grows only 1.5 feet every year, 1.5. All right, when will they be the same? When does 2.5x plus 6 equal 1.5x plus 16? Okay, I'm going to minus 1.5x from this side, minus 1.5x from this side, and I get 1x, or x, plus 6 equals 16. I'll subtract the 6 from this side, move it over here, and x equals 10. In 10 years, they'll be the same. All right, copy that because I think some of these are way too hard. I don't like the different difficulty levels in here. So copy all mine. Just, I'll give you easier problems in the test. I don't think this is a realistic representation of what you should be able to do. So yeah, copy it. Just know that it exists. Hopefully it wasn't too crazy. And if you copied it, no big deal. All right, see you tomorrow.